Hello? Hello, hello. Hi. Thanks for coming. Hi everyone, I'm Dario. I'm going to cover mixed reality. That's me in a mixed reality of Arcade Saga, an early version of it. What are we going to cover? So quickly, in the 20 minutes allotted, I'm going to cover. It's just a review of mixed reality, green screen mixed reality, how it works for those who are new to it. I know it was kind of clickbait to say death camera without much of a description. I remember submitting that months ago, and I failed to put a description. But there's a good reason for it, and I'll explain it when I get to it. In fact, spoiler is right here. The ZED camera. This is what I'm going to show. And special thanks to StereoLabs, because, as I'll announce later, they've made tools available as of today. Quickly. So my main message, if there's any takeaway from here, is that you really need to have mixed reality as a checkbox in your feature list when you're developing an application or experience. Don't rely on out-of-the-box support. I know SteamVR did a great job in adding that in, and most people who are developing for Unity will use the SteamVR plugin. So it's kind of been like a default support. It doesn't mean it's the best support. It's good. But what I'm trying to imply here is that a lot of people are thinking, oh, you just can't do it in Unreal, for example, when you can. It's just a matter of taking the effort and making developers know this is a feature. You got to implement it and make it useful to the end user. Right now, you have to have like a configuration file, and I'll get into in detail a little bit. And you have to have a third controller. That's not necessarily true if you know how to develop and put a little configuration or settings in VR, in fact, and you can actually help the user set up for mixed reality. So because of that, there's only a handful, maybe 3, 4 or 5 studios actually doing their own custom support with nice UI for user-facing UI. But hopefully that will change soon. So the story so far, just a quick little history recap. So the teams behind the fantastic contraption game were the first to really display this functionality. In fact, it was one of them who coined mixed reality. I gave him a little of my objection to that. But basically, that was January of last year. So it's already been over a year since we've been seeing these mixed reality videos. The primary use, like in this case, was on Twitch. And again, you can use promotional videos. There's a lot of different use cases, and I'll go over some of those. How it works currently for mixed reality, it's a sandwich of sorts where you have 3 layers. You have the background, you have the middle, which is your green screen video, and you have your foreground. At first, you have to think about how that looks like in action. So objects will pop in and pop out of you as you walk through them, depending whether they're in front or behind the HMD. So it's the HMD that's determining the cutoff point. So SteamVR, a couple of months later in March of last year, they decided to let's just build this in so that everyone who's developing in Unity will have this support as part of the plugin. And it's very simple. All you need is to add a configuration file where your runtime resides and a third controller. And once you do that, this is what you get in your game window on your desktop. Basically, you have a divided screen in 4 quadrants. You have a foreground, a background. You have the HMD view itself, and you have a foreground alpha. So that's in case you want to have like a transparent foreground. A lot of people don't realize that and will forget that. I initially did that too. But you really need the 3, the background, foreground, and the foreground alpha. Optionally, you want to, in case you're in Twitch, or you want to in real time switch to HMD view. You have the capability of doing that. And then you composite everything with a software tool like OBS. I know there's XSplit as well. I think OBS is still good. They've been fixing a lot of the bugs over the year. So this is how you put in order the foreground, your green screen video, and your background, and it gets composited together. And you can do this all on one machine, or you can have a capture card in a dedicated machine, and then combine them on a separate box. Now, there's many online guides over the past year. This is one of the most known, Kurt Garner. He made the videos for the professional trailers for Fantastic Contraption and Alchemy and a lot of other ones. Job Simulator. The pain point. So I've seen a lot of these guides. In fact, there's even one called the Comprehensive Guide. But they all skip over the really painful point when you're doing mixed reality, is getting these configuration, all these numbers right. And what these numbers are is really the offset between your virtual camera and your real camera. So they have to be in sync, and you have to actually, for that third controller that's representing your virtual camera, you have to make sure the offsets are correct, the field of view of the camera is correct. A lot of trial and error. Initially, we were all just editing this file and doing trial and error, just look okay. Eventually, I got a little tiresome. And by the way, this is still a problem even with depth cameras. So that's why it's important to point it out. So addressing this issue. So I've seen a lot of people try to address the issues writing custom software. Like, for instance, this guy, he does a little neat thing where he, let me just forward a bit. He takes this software he wrote, and he basically uses the controllers to go to each corner and visually helps you line up the controller, the virtual controller with the real controller. And you just get to a point where you can show you, where you can actually see right here. Yeah, so you see the virtual and the real, and the idea is you have to match them almost identical. It's very difficult, but you can do it. So this is better than just editing a configuration file, but it still requires a lot of trial and error, a lot of visual trial and error. So let me just go to the next slide. So there's other ones. This one on Steam that's actually has a monthly fee. And what that does is, within virtual reality, you see a mirror of yourself. And then you actually adjust that mirror in different angles until you get the right field of view and all these other values and so forth. There's even this other one recently that I learned about that was funded by Intel from this company that, again, they're doing a combination of NVR, video displayed in VR. So you have all these combinations, but ideally, I think, in the long run, we'll need some kind of computer vision solution so that it's more automated and more error-free. So what about Unreal 4? Unreal Engine. What about it? Just add it in. Like I mentioned before, it's not rocket science to understand how it works, what virtual cameras you need, that you need to actually get a video feed, either composite inside the engine or use an external OBS type software to composite it. You can do post-production to get really good quality. I think, actually, I spoke to Epic, and they really prefer you to have a different machine to do the capture, because, of course, it's all about quality. And that's one thing I want to emphasize. You may get a performance hit, so you make sure you always hit the 90 frames per second when you're doing a custom version of the mixed reality support. In fact, for a lot of reasons, maybe that's why the support in Unity from Steam is very simple, and it's assuming you're going to composite it externally. So it gives you an idea of how simple it has to be for it to be performant. There's a lot of people who actually have examples of how to do it in Unreal. This very recent blog that is really a good example. In fact, let me show you a video of it. I'll just click here. So if you're on Unreal, I recommend you check out this article. Let me just play this video quickly, just to give you a sense of you can get really good quality inside in Unreal. And this is a very simple implementation using blueprints, actually. So you get the idea, you're doing mixed reality. It doesn't have to be Unity. All right, so let me resume this. No. Here we go. So next, well, we're going the other way. And then this happened in October 2016. Alchemy, the creators of Job Simulator, decided to tell the world about what they're working on for several months, actually. And it's the idea of using a depth camera to do mixed reality. And I'm not going to show you the video. You can see that, and you've probably already seen it. But I chose this still for a reason. I think this illustrates very clearly when you're reaching over an object like this drawer. This is illustrating how you have to have depth, per pixel depth, to be able to pull that off. To be able to put an object between you, like a ball, in your hands and go around it. So it's no longer based on where your headset is. It's actually based on the depth camera information, the depth map that's collecting and doing a per pixel distance and just compositing that in your app itself. So there's a lot of benefits with this. So I mentioned per pixel depth. It allows you to do all those things you can't do with regular mixed reality. In-app compositing, so you have to use OBS afterwards, and it doesn't even require a headset. You can go in there and not wear a headset. With some effort, and they've done this, and you can add lighting effects to the person in mixed reality. You can have multiple people in mixed reality, which you can't do now. And you can even have a preview of the composited video inside their space. So they can look at the camera and see a screen and see themselves composited in mixed reality, which is pretty cool to see themselves inside VR being mixed. What is depth map? So basically, you create a map, and in this case on the right, the darker pixels are the closer pixels. But basically, you use, in this case, well, I'll talk about the cameras in a bit. In a nutshell, basically, you're using the two stereoscopic views to create this depth information. And this has been going on for a long time. In fact, HTC had a phone, the HTC One M8, that had two cameras for dual lens for this purpose. And in fact, anyone who's taking a picture with that camera's got the depth information for every picture. And you can bring all those pictures to life in 3D in VR. So just an interesting note. Because I've been giving a lot of talks for that SDK back in 2014. So I know about depth. These are the depth sensors that are out there. This is a review from December. It's a little outdated already, but there's a lot of cameras out there. There's everything from Intel to Microsoft and of course StereoLabs ZED stereo camera. What makes this a little different from the rest is that the other ones are infrared based. This is not. This is just RGB. So it's really using the stereo processing of the two cameras to do the depth. So now we're up to, good, I have time. We're up to, that's just the background, but basically we're here to talk about depth camera and how to use it in Unity. So as of today, coming to the present, StereoLabs has released the ZED 2.0 SDK, and that includes a lot of examples, and it also includes support for green screen mixed reality. So, and here I'm showing the tracking being done by the Vive tracker. So as of this past Monday, this went on sale. It's actually already sold out, but we're going to get more, so you can actually pre-order yours for the next batch. So basically what I do is I put it on the camera, and again, it's all about getting those values right between your virtual camera and the real camera, in this case the ZED camera. So I'm going to generally put it here, but the axes of this, and this is all documented in the documentation for the tracker, how to do the matching the axes. It's relatively simple, just to keep in mind Z is coming out of the tracker. So you have to do rotation and positioning. I generally like to make it easy and try to line it up, guesstimating visually that it's over the left camera, which is the one that's composited, and that it's facing the right way. So I'm just going to place that there. And we'll see if this experiment works. really have a flimsy tripod here, but let me just make sure it's extended. No, it wasn't. I got it. So, by the way, I don't know if you guys noticed when I came in, this is a record time of setting up the whole live. Although I haven't actually done the setting up the room, but I want to do that live just to talk about some things that depth cameras can do for that. Okay, so here's a video of me illustrating, same setup. It's actually not really a good example because I only had a single source of light, which is not advisable when you're doing mixed reality because you can see the green in the back of me. But basically what I want to illustrate there is that I can have there's going around my head and going around my hand. So there's actually several depths that I'm illustrating. And you can't really do that with the previous way of doing mixed reality because things will either pop in or pop out. And just it breaks that from a viewer point of view. So demo time. Let's go Unity. Before that, I'm going to set up things. See, we're almost there. So there's several examples here. Let me just walk through some of these scenes. So once you install the ZED 2.0, oh, and I got to talk about, for this specific camera, the reason why it's very performant is because it's using NVIDIA's CUDA extensions. So that's maybe a drawback because you need to install that to get this working. And obviously you can't expect every user to have that. So that's a kind of a requirement if you really want to, for now, using this camera to do depth MR. So there's several scenes. There's simple tracking VR, and again, I'm focused on MR, but of course, this camera has so much more capabilities as a depth camera, from mapping areas, from tracking where it is in space as well. So it has its own tracking. I'm obviously choosing to use the lighthouse tracking because it's a little more accurate, but you can actually use the depth camera's tracking itself. It's more process intensive. That's why this combo is still required. It comes with these examples. There's tracking VR, simple tracking. There's this simple MR, mixed reality, and another meaning augmented reality. In fact, I'm going to try that first, but before I do that, let me just quickly run the room setup. And the reason I want to run room setup with you is just to point out for this configuration which way you should be pointing when you set this up. And also to talk in general about how in the future I predict that this manual room setup is going to go away thanks to depth cameras. Can anyone guess why? It can map the room for you. And it could automatically determine the play area space. Yeah, and any furniture and anything in the room. All right, so let's just quickly set this up. So I want to be facing this way, obviously, because I only have one base station, which makes sense, and that's why I put this behind me, because generally you want that behind the starting direction you're pointing at. So I just reversed that, didn't I? I want to face this way, so I should have pointed that way, but I could switch it after. I'm going to calibrate the floor quickly. So we're doing this from scratch, and hopefully we get a result. I usually choose advanced because for me it's a lot easier. You can edit it afterwards too. So I'm going to do roughly, I may need to go further. It's pretty small here. losing tracking. That may be too small for this to work, so. Nope, it worked. Am I facing the right way? This way? Nope. So in fact, let me edit this. I'm actually going to make it smaller so I can spin it around because I want it to be facing this way. If I can capture this. It may not let me do it smaller. Let's see, let me go back. Let's just quickly redo it. And am I facing the right way? Yep. Okay, we can party now. All right, so maybe I'll just run it and show you what it looks like. Well, I'm going to run the first example, the simple MR one. So I don't actually have a green screen here, so I just want to show you how it does depth using the camera. It's not seeing the camera. Let's try this again. Yeah, nothing like live demos, guys. So what I'm going to do is to connect it directly. Hopefully that'll work. Let me just show you some of the tools that the SDK comes with. In fact, that's one way I can test to see if the camera's connected. Here's the depth viewer. This is native depth viewer. And I think it's offline, so that's a good way of testing. So the ZED camera uses USB 3. Just making sure it's connected. I'm going to swap ports. And because I ran out of ports already, I had to use a hub, so I can add the dongle for the actual tracker. There you go. So that's this example here. I have not added VR into it yet, but see, this is, I don't know if you can see those objects, those 3D. You can sort of see some come and go. It's hard. Maybe the lighting is not great, obviously, here, but it gives you an idea. I'm going to run the next example, which is the green screen one. Of course, Unity crashed. That's the demo gods always at work. Now look at this running. So it's a simple scene where you have, like, you're in a desert scene, there's a gas station, you have, oh, okay. I'm being told I'm running over. But this is exactly what I kind of showed you it working sort of. With the green screen, obviously, it would work much nicer. Just to wrap up and just go back to my slides. I'm going to have this working on the floor. You can visit either the HTC booth or the ZED camera, StereoLabs, is also at a booth. at the upload booth. So please stop by, check them out. Just some additional ideas. We just mentioned we can actually do the setup using depth camera. And of course, once you start using OpenCV, the possibilities are endless. Here are some additional resources. And follow me on virtual, Dario, and thanks for coming.